minute, as many of my things are harebrained and don't always work, I thought, well, the way to learn is to share it and maybe get some feedback. Got some comments. So I started a project and I decided it would use some things I knew something about, little about. That is, I decided my tractor, I have a John Deere tractor, and the alternator seized, and I found one on eBay for $30. And you know, it's nice. It's kind of lightweight. It's basically it's 20 amp, makes 20 amps, easy to rotate, has a built-in pulley on it, kind of small enclosure. And I started thinking, I was like, well, wonder if I could make a windmill. You know, everyone's talking about electric and doing this and that. And, you know, so the next thing I started doing was I went online. I was like, well, you know, the next most complex piece of this really is the blades, you know, and connecting the blades to power this thing. And I went online and I researched maybe a dozen or so different little windmills for farmers and the various accessories. And I felt that none of them were suitable. They looked like toys or they were ginormous. And this is not either of those. And I don't really want it to be a toy. I mean, optimally, you know, it will produce electricity. And I have some inverters that I would use for turning it into 110 charging batteries or whatnot. So that's the start of the project. So after an exhausting search on the internet, I decided I would use Autodesk Fusion 360 and draw my own blade holder. This ultimately, I decided on a 6-blade design. This would be the foundation for the rotary head for the windmill power generator. I drew this out and then I, you know, ended up going with some stock components, a 3/4 inch shaft with a keyed area, and then a place I could put a set screw to hold the shaft in position. I realized that if I was going to sand mold this, I needed to make a core and a cavity, a core for this area here because there's going to be some serious undercuts that I did not want the cast to infiltrate that area. I could later machine it, you know, as necessary. So then, you know, taking this a little bit further, I realized, well, I can start doing some additional things here. I put my shaft on, I put it onto a plate of steel. I added another back plate to it, and I was like, okay, this is coming together as a sandwich. There's a standard block, you know, a dot bearing surface here, a bearing here, and then I was like, okay, let's get working on the casting process because I can work on the metal while this is casting, and actually I needed to 3D print it. So then I went ahead and I was like, well, okay, I've got to make the core itself, and I ended up making so the core is going to be made out of sand. So I actually am going to make a mold that's going to make the positive image of the part. So if you envision now, this is all going to be filled. This is going to be filled with sand here as well as down inside this tube up until that point. That's going to make the hollow for the 3/4 inch shaft. Then I took it to my Dremel. Slicer, and that was the next step. So this is an example. It shows you the core mold located inside of the Dremel, inside of the slicing tool. And here I took the part and, you know, I placed it on the surface that ultimately is where the model will be cut. And I decided, because I'm going to build supports inside of this, that I would uh, lay it in a way that had the least amount of supports inside of the area where I wanted the finished part. Now, because ultimately what's going to be finished here is this inside surface, this inside area is what's going to be the sands for the cavity that's going to go inside of the plastic part that I'm also printing. This would in turn, I would like the smoothest surface. So the supports are going to be built underneath here. So there's going to be some little detail that's going to be, unattractive, kind of physically affecting this surface here in the finished product. So then I slice this. I'm using PLA. I slice this and I save this as a model, and that in turn will be, our molds for this, our molds for this, for the part itself. So that's kind of the start of it. And I want to show you it in the process of being made inside the printer. Now I'm going to be jumping to the fan blade assembly when I do that. So here I have my core that is inside of the slicing tool. And I'm going to position these in a way such that they make the least amount of support structures, which are kind of additional features necessary to build a 3D model, in the finished product, on the finished product. So I'm standing them unconventionally up. Now I want these holes later on to be there, but those I can just drill out. I can clean the support structures out of them. And here, but what I want to save, what's most important to me, is this inside, this detail, all this interior work. So what you have here are the two halves of the mold that will make the sand core. And that will be printed. There will be some supporting going on there, but that's all not important to me. So this now is for making the insert that's going part of the fan. I'm going to show you the fan operation shortly.
Then I started printing. This is the fan blade at this point. It's one half of the blade, and it takes about 60 hours for it to be completely printed. It's fed off that spool to the printer head up in the back, and in turn extruded onto the part in a pattern. Because of its physical size, I had to do it in two pieces. So this is the first part that's been printed, and it, again, 60 hours. So that's the other half of the piece, and this is where the core will go inside of here, and there's the pan itself. So that's the other half. The next thing I wanted to do was to make the core boxes in which these two parts would fit. So I had some old wood from an older project and ultimately cut them down. I made two core boxes. For the next generation, I went even a little bit larger because I decided I was going to make a frame, the actual, where you saw sheets of metal, I'm actually going to make it a framed bottom where it's cast. So it's not just a flat sheet of metal, it actually has 3 dimensions to it. So in the meantime, as I have no foundry set up right now, I decided I would build a deck like a surface where you could have this very hot metal and not cause any fires or cause real damage. And certainly I didn't want it inside, so this had to be outside. And here I've built this patio, and I started with some fire bricks here in the corner. I'll get some more to fill it out. It'll give me a nice surface for working and pouring the metal.